Welcome to tonight's episode of Science to Sleep By. Together, we'll take a slow, gentle dive into one of the most fascinating thought experiments. What if gravity, the very force that keeps our feet on the ground and the stars in their orbits, suddenly vanished? We'll follow this idea step by step, imagining the world without gravity while learning the science behind it, all in a relaxing, soothing rhythm to guide you into deep rest. Gravity is something we live with every single moment of our lives, yet most of the time we hardly notice it. We wake up in our beds, and our bodies remain gently pressed against the mattress. We place a cup of coffee on the table, and it stays there instead of floating away. We take a walk down the street, and each step is guided by the steady pull of gravity drawing us toward the Earth's surface. This invisible force is so constant, so reliable, that we take it for granted. But to truly appreciate the idea of what might happen if gravity suddenly stopped working, we must first spend time understanding what gravity really is, and why it has shaped the universe into the place we know today. Gravity is often described as the weakest of the fundamental forces of nature, but also one of the most important. It does not work like electricity, which sparks brightly, or magnetism, which can pull and push objects in visible ways. Instead, gravity is a quiet, steady force, working silently in the background, without any visible trace. It is the attraction between any two objects that have mass. You and I, for example, technically pull on each other with gravity. The chair you are sitting on pulls on you, and you pull on it. But these forces are tiny, almost unnoticeable, compared to the massive pull of the Earth beneath us. Earth's mass is so great, and its presence so vast compared to our small bodies, that it dominates our experience of gravity. That is why we feel drawn to the ground, even though technically we are being pulled in countless directions at once by everything around us. To understand gravity, scientists often speak of space as if it were a kind of fabric. Imagine stretching a large, soft sheet across a frame and placing a bowling ball in the middle. The ball sinks down, creating a dip in the sheet. Now imagine rolling a marble across the fabric. Instead of moving in a straight line, the marble curves around the bowling ball, circling it before spiraling inward. This is a simple way of picturing how gravity works in our universe. Massive objects like stars and planets bend the very fabric of space and time, creating pathways that smaller objects follow. The Earth, with its great mass, bends space enough to keep the moon locked in orbit. The Sun, far more massive still, bends space in a way that holds Earth and all the other planets within its reach. Gravity is not just a pull, it is the shaping of the universe itself. The discovery of how gravity works is a story that reaches back centuries. In the 17th century, Isaac Newton famously described gravity as a force pulling objects toward each other. Legend tells us that he watched an apple fall from a tree, inspiring him to wonder why objects always fall downward, always toward the center of Earth, and never sideways or upward. Newton realized that the same force that pulled the apple to the ground must also be at work in the heavens, holding the moon in orbit around Earth and keeping the planets in their paths around the sun. His equations described gravity as a universal force, acting between all objects in the cosmos, no matter how large or how small. This was a profound step in human understanding, connecting the familiar fall of an apple to the vast motion of celestial bodies. Centuries later, Albert Einstein reshaped our understanding of gravity once again. In his theory of general relativity, Einstein proposed that gravity is not a force in the traditional sense at all, but rather the result of the way mass and energy bend space and time. His insight gave us a new picture of the cosmos, one in which space itself can curve, stretch, and ripple. This idea was confirmed through countless experiments and observations, from the bending of starlight around the sun to the detection of gravitational waves rippling across the universe. Einstein's view of gravity as the geometry of space-time remains one of the most elegant descriptions of how the universe works. Even with these great breakthroughs, gravity still holds mysteries. Unlike the other forces of nature, gravity is incredibly weak on the scale of atoms and particles. If you hold a small magnet near a paperclip, The tiny magnetic force is enough to lift the clip against the entire pull of Earth's gravity. And, yet, despite its weakness, gravity dominates the universe on large scales. It is gravity that pulls clouds of gas together to form stars. It is gravity that shapes galaxies into vast spirals and clusters. It is gravity that ensures the planets, moons, and countless asteroids dance together in their endless cosmic ballet. Without gravity, the universe as we know it would be unrecognizable. For us here on Earth, gravity defines the rhythms of our lives in ways both subtle and profound. It is what makes a ball arc through the air when thrown, what keeps rivers flowing toward the sea, and what causes the tides to rise and fall under the moon's influence. It guides the growth of plants, pulling their roots downward into the soil while their stems reach upward toward the sun. Our own bodies are adapted to the gentle pressure of gravity, our bones strong enough to bear our weight, our muscles tuned to resist its steady pull. Even the fluids in our bodies circulate differently because of gravity, ensuring blood flows properly through our veins and arteries. From the largest galaxies to the smallest details of our biology, gravity weaves itself into everything. Yet despite its familiarity, gravity is strangely elusive. Scientists still wonder whether gravity might have hidden dimensions or connections to forces we have not yet discovered. Theories of quantum gravity attempt to unite Einstein's curved spacetime with the world of subatomic particles, but no single solution has been agreed upon. The mystery of dark matter and dark energy, invisible substances that make up most of the universe, also appears deeply connected to gravity, shaping galaxies in ways we cannot yet fully explain. This means that even as we rely on gravity every day, and even as we teach its principles in schools and use them in engineering and space exploration, the deepest truths of gravity remain just beyond our grasp. When we pause to reflect on gravity, in this way, it becomes something almost poetic. It is invisible, yet it shapes everything. It is weak in one sense, yet it governs the grandest scales of the cosmos. It holds us, cradles us, and defines the very possibility of life on Earth. And as we imagine a world without it, we can better appreciate the world with it. The force that presses us gently into our beds each night is the same force that keeps the moon aloft, the same force that forms stars, and the same force that ensures the universe holds together rather than flying apart. On our planet, gravity is more than just a background presence. It is the very architect of Earth's landscapes, the sculptor of its oceans, and the keeper of its delicate atmosphere. Every feature of life as we know it has been shaped, guided, and sustained by the steady pull of gravity. Without it, Earth would be nothing like the world we live in. To truly imagine what would happen if gravity suddenly stopped working, we must first pause and reflect on how gravity currently holds everything together, moment by moment. From the air we breathe to the ground beneath our feet, gravity's most immediate role is the simple one we experience every day. It holds us to the surface of the Earth. We seldom think about this as we go about our lives, but without gravity's invisible hand, our bodies would not remain anchored to the ground. Every step we take relies on the Earth pulling us down again, ensuring our feet return to solid ground. When a child jumps into the air, when a basketball arcs toward the hoop, when autumn leaves fall softly from a tree, gravity is guiding each of these motions with quiet precision. It provides order, a predictable rhythm that shapes how we move and how we live. Yet gravity's influence on Earth extends far beyond simply keeping us in place. It also shapes the very form of our planet. When Earth first formed billions of years ago, it was gravity that pulled scattered dust, rock, and gas together into a growing sphere. As the planet grew larger, gravity pulled it into the round shape we recognize today. Without gravity, Earth would not be a globe at all. It would be a loose, chaotic cloud of materials drifting through space. Even mountains, those towering giants of stone, exist only because gravity holds them rooted to the planet's surface. Over millions of years, gravity has pulled rocks, sediments, and tectonic plates into their present positions, building continents and carving valleys. Gravity has been, and continues to be, the architect of Earth's terrain. One of the most beautiful ways we experience gravity on Earth is through the behavior of water. Oceans, lakes, and rivers all owe their existence to gravity. Water always seeks the lowest point available, flowing downhill in streams, gathering in valleys, and filling basins to create the seas. Without gravity, there would be no downward, no direction to guide water's flow. Rain would not fall, rivers would not run, and the seas themselves would not stay in place. Imagine standing on a beach, waves rolling gently toward the shore, the tide moving in and out. All of this is possible only because gravity draws the water toward Earth's center, while also being tugged and teased by the pull of the moon. The tides are one of the most elegant demonstrations of gravity's influence, showing how Earth and its companion in the sky are locked together in a graceful, endless dance. The atmosphere, the very air that fills our lungs, also remains with us only because of gravity. Without this constant downward pull, the blanket of gases surrounding Earth would drift away into the vacuum of space. Instead, gravity gently holds the atmosphere close to the surface, thickest at ground level and gradually thinning as it stretches upward. This invisible ocean of air sustains every breath we take, protects us from harmful radiation, and keeps our planet warm enough for life. Each molecule of nitrogen, oxygen, and carbon dioxide is bound to Earth by gravity's patient grasp. If you step outside on a quiet evening and take a deep breath of cool night air, you are directly experiencing one of gravity's greatest gifts. Without it, there would be no air to breathe, no weather to change with the seasons, and no climate to shape the cycles of life. Gravity also plays an important role inside our own bodies. Our muscles and bones have developed to work against its steady pull, growing strong and resilient in response. Our hearts pump blood upward, against gravity, to deliver oxygen to our brains. Even the way we sleep is influenced by gravity, as our bodies settle gently into the mattress, supported by the downward force of the Earth. Astronauts who spend long periods in space, free from gravity's constant pull, experience profound changes in their bodies. Their muscles weaken, their bones lose density, and their circulation changes in surprising ways. Returning to Earth, they must readjust to the familiar weight of gravity pressing on them once again. This shows us how deeply gravity is woven into our biology, shaping not only the structure of our planet, but the very structure of life itself. Plants, too, live in constant dialogue with gravity. Their roots grow downward, sensing the pull of Earth, while their stems and leaves reach upward toward sunlight. This dual response, known as gravitropism, ensures that plants can anchor themselves in the soil while stretching toward the energy they need from the sky. In every forest, every meadow, every garden, countless stems and roots are quietly following the guidance of gravity, building the green world that sustains us. If gravity were to suddenly vanish, the intricate systems plants rely on would falter, and the balance of ecosystems would collapse. Even here, in the smallest details of life, gravity is the silent partner that makes growth possible. The influence of gravity on Earth also extends to weather and climate. Warm air rises, cool air sinks, and winds flow across the surface of the planet because of differences in pressure and temperature, all behaviors that depend on gravity holding the atmosphere close. Clouds gather, rain falls, snow drifts softly to the ground, all thanks to gravity's pull on water droplets and ice crystals suspended in the sky. The simple fact that rain falls downward, nourishing crops and filling rivers, is another everyday miracle of gravity at work. Each cycle of evaporation, condensation, and precipitation is part of a grand system sustained by this invisible force. Even human history has been guided by gravity's influence on Earth. Ancient civilizations learned to harness gravity to move water, building aqueducts that carried streams to their cities. Farmers relied on gravity to irrigate their fields. Millwrights built water wheels that turned with the steady flow of rivers, powered by the downward pull of water seeking its lowest level. Gravity has quietly powered industry, agriculture, and exploration throughout the ages. Today, engineers, Still design systems from plumbing to hydroelectric dams that depend entirely on gravity's consistency. In many ways, gravity is also the reason Earth remains a home for life at all. Without its pull, the planet would not hold on to its oceans or atmosphere. Without those, temperatures would swing wildly between day and night. Radiation from space would strike the surface unfiltered, and the conditions for life would be destroyed. Gravity creates the stability that living systems need to evolve and flourish. It ensures the delicate balance of water, air, soil, and climate that sustains ecosystems from the deepest ocean trenches to the highest mountain peaks. When we reflect on this, it becomes clear that gravity is not just a background force, but the silent guardian of Earth's habitability. Everywhere we look, from the simple fall of a raindrop to the rise of mountain ranges, gravity is present. It is there in the tides, in the breezes, in the slow flow of glaciers. It is there in the beat of our hearts, in the branching of trees, and in the cycles of weather that bring us spring and autumn. Gravity's fingerprints cover every feature of the Earth, every system of life, every rhythm of the natural world. It is so constant, so dependable, that we rarely pause to notice it. And yet, without it, the world we know would unravel instantly, dissolving into chaos. Imagine, just for a moment, that gravity were to stop working. Not gradually, not over years or even hours, but instantly, in the blink of an eye. 1 second. Everything feels familiar, your body pressed comfortably into your chair, your coffee mug resting securely on the table, the air surrounding you dense and steady. And then, in the very next second, the invisible force that holds all of it together vanishes. The first moments without gravity would be unlike anything humanity has ever experienced, a surreal and disorienting transformation of the world we know. The very first sensation you would feel would be weightlessness. The pressure of your body against your chair or your bed would disappear, and you would begin to float upward, not pushed, but simply no longer pulled down. It would feel as though the ground beneath you had lost its meaning, as though the very concept of down no longer existed. Objects around you, books, pens, cups, pillows, would begin to drift slowly into the air, joining you in a silent ballet of motion. At first, it might seem almost gentle, like being suspended in a dream, but the reality would be far more chaotic. Our atmosphere, held in place only by Earth's gravity, would begin to slip away immediately. Air molecules, which usually cluster densely at the surface of the Earth and grow thinner with altitude, would scatter outward into space, no longer tethered to the planet. Within minutes, the air we rely on for every breath would begin to dissipate. The comforting resistance we feel when we move our hands through the air, the invisible cushion that carries sound waves to our ears, would start to thin. Voices would grow quieter, harder to hear. Breathing would become more difficult as the atmosphere slowly escaped. The world would start to feel eerily hollow. Water would join the strange exodus. Oceans, lakes, and rivers, once drawn downward toward Earth's center, would no longer have any reason to stay in place. The surface of the sea would ripple, then rise, as water began to drift upward in great globes, breaking free of its container. Rivers would leave their beds, streaming into the sky in glistening strands. Even the smallest glass of water would lift out of its container, droplets drifting into the air, surrounding you in floating beads of liquid. The sight of it would be mesmerizing, like watching pearls of crystal hover and scatter, but it would be only the beginning of the immense changes to come. The first moments without gravity would also disrupt the ground itself. Buildings, rooted firmly into the soil by their own weight, would begin to tear away. At first, the weakest structures would shift, a chair sliding slightly, a picture frame tilting off the wall. But soon, larger and heavier objects would follow. Cars, houses, entire sections of cities would lift gently at first, then with gathering momentum, rising from the Earth's surface. People would float alongside them, unable to hold onto anything for support, drifting upward into the open sky. The very idea of a stable floor would dissolve, replaced by a strange and endless upward motion. Animals, too, would experience this sudden weightlessness. Birds, so used to flapping against gravity's resistance, would find their wings useless in the absence of air density. They would drift helplessly alongside the trees that once held their nests. Fish would rise with the water that surrounded them, their entire ecosystem suspended in strange bubbles breaking free of rivers and oceans. Even insects, which rely on air currents and surfaces to land upon, would lose their rhythm, their tiny bodies caught in the same drifting dance as everything else. The harmony of ecosystems, built over millions of years under the steady hand of gravity, would collapse in an instant. Human bodies would not be spared from confusion. Our inner ears, which rely on gravity to help us sense balance and orientation, would suddenly lose their anchor. The world would spin in ways that made no sense, with no clear direction to guide us. Nausea, disorientation, and panic would quickly follow. Muscles designed to resist weight would suddenly feel unnecessary, and our sense of up and down would vanish entirely. Floating in this weightless chaos, surrounded by drifting objects and disappearing air, survival would become uncertain in mere moments. Yet even as the world unraveled, the first seconds would also reveal something profoundly beautiful. Without gravity to hold it close to the surface, dust and pollen would scatter into the air like stardust. Leaves and branches would drift away from trees in slow, graceful arcs. Papers, feathers, and fabrics would spread in gentle clouds, each one suspended in motion. The sky above would grow darker, not because night had fallen, but because the atmosphere itself was escaping, revealing the blackness of space beyond. Stars, once hidden by the blue veil of daytime, would shine faintly, even in what had been noon. In those first fleeting moments, the earth would begin to resemble a dreamlike painting, filled with floating fragments and a horizon dissolving into space. Technology and infrastructure would be thrown into immediate crisis. Airplanes, designed to move through an atmosphere that no longer existed, would lose lift and drift uncontrollably. Satellites in orbit, once balanced by the pull of Earth's gravity, would continue on their paths in straight lines, no longer bound to circle the planet. Power lines, pipelines, bridges, and roads, all structures built on the assumption of gravity's constant pull, would suddenly find themselves strained in ways their designers never imagined. The systems we rely on every day would break down almost instantly. Even sound itself would change. As the atmosphere thinned, sound waves would struggle to carry through the diminishing air. Voices would become faint, then silent, replaced by an eerie stillness. The familiar noises of the world, the hum of engines, the rustle of leaves, the distant bark of a dog would vanish into silence. In those moments, the earth would become unsettlingly quiet, as if holding its breath. The very ground beneath our feet, normally firm and stable, would lose its meaning as the earth's surface began to crumble without pressure holding it together. Soil, sand, and rocks would loosen and drift upward, breaking into clouds of particles. Mountains and valleys, which seemed eternal, would begin to scatter into space. Even the earth itself, no longer held into a sphere by gravity, would eventually begin to fragment. But in the earliest moments, it would be the details we notice first. A pen floating off the desk, a sip of water escaping its glass, the air itself becoming thinner with every breath. The first minutes without gravity would leave us suspended in confusion, floating amidst the familiar objects of our lives, now unmoored and drifting. It would be disorienting, terrifying, and strangely beautiful all at once. The world as we know it, stable, ordered, predictable, would unravel before our eyes, leaving behind a surreal landscape of floating oceans, scattered air, and silent skies. The atmosphere is our invisible shield, a soft, protective blanket that surrounds the earth and makes life possible. It is something we rarely notice, because it is always there, enveloping us with every breath, filling our lungs with oxygen, carrying sounds, shaping clouds, and holding warmth close to the surface of the planet. We do not feel its weight pressing down on us, though it stretches many miles above our heads. Yet the atmosphere is not bound to Earth by anything more than gravity's steady pull. If gravity were to suddenly vanish, one of the very first and most dramatic changes we would experience would be the escape of the atmosphere, slowly at first, and then with an unstoppable rush. Picture yourself standing outside on a quiet evening. The air feels cool and soft on your skin. Each breath comes naturally, automatically, without effort. But if gravity were gone, this familiar comfort would begin to unravel. In the very first seconds, the molecules of nitrogen and oxygen that make up the majority of our atmosphere would no longer be tethered to Earth. Instead, they would begin to drift upward, rising into the black expanse of space. Air, which we think of as weightless, is in fact held firmly in place by gravity. Without that binding force, it would no longer cling to the surface, no longer hug the planet in its invisible layers. The process would not be instant, but it would begin immediately. Imagine watching the sky as the density of the air begins to thin. At first, you might feel your breathing change. Each inhalation would bring in a little less oxygen, a little less pressure filling your lungs. The sound of your own breath would grow louder, more hollow, as the air around you began to disperse. Speaking would become difficult, your voice sounding weaker and fainter as the atmosphere thinned. Conversations would be lost to silence, carried only a short distance before fading into nothing. The air that has always been our companion would start slipping away, and with it, the very sense of being grounded on Earth. The escape of the atmosphere would also change the sky itself. The familiar blue that stretches above us is created by sunlight scattering in the thick layers of air. Without those layers, the sky would gradually lose its color. Within moments, it would deepen into a darker shade, moving quickly from pale blue to a dusky indigo, and finally to the blackness of space. Stars that are usually hidden by daylight would begin to appear, faint at first, then shining steadily. Even in the middle of the day, constellations would emerge as if night had suddenly arrived. The sun, still burning with its steady brilliance, would shine against the stark contrast of a black sky, no longer softened by the scattering of air. Looking upward, you would feel as though Earth had already drifted away from its familiar home and stepped into the vacuum of space. As the atmosphere slipped away, the air pressure on Earth would fall. Normally, the pressure of the atmosphere presses on us from all sides, a weight we do not notice because it is constant and because our bodies are adapted to it. But without it, our ears, our lungs, and even the fluids in our bodies would feel the change. Breathing would become not only difficult but eventually impossible, as oxygen no longer gathered in sufficient amounts. The moisture in our eyes and mouths would begin to evaporate more quickly, pulled into the emptiness above. In a matter of minutes, the very act of living would become unsustainable as the protective blanket of air unraveled. The winds, too, would vanish. Breezes that rustle the trees, gusts that move across the plains, the howling of storms, all of these are movements of air, guided by pressure differences and Earth's rotation. Without an atmosphere, there would be no more winds. The sound of leaves rustling, the waves crashing against the shore, the whispers carried on the breeze would disappear. Silence would deepen, broken only by the faintest vibrations through the ground. The Earth would become eerily still, as if time itself had slowed. Weather as we know it would end. Clouds form because of condensation in the atmosphere, shaped by temperature and movement of air. Rain falls because droplets are pulled down by gravity, guided through air toward the ground. Without gravity and without atmosphere, clouds would no longer form, and rain would never fall. Storms, hurricanes, and snowfalls would vanish. The cycles of weather that define our days and seasons would collapse, leaving only the bare and silent exposure of the earth beneath the sun's unfiltered light. The comforting cycles of cloudy mornings, rainy afternoons, and snowy winters would no longer exist. Without an atmosphere, Earth would also lose its shield. The atmosphere protects us from harmful radiation, scattering ultraviolet rays, blocking cosmic particles, and softening the impact of small meteors. Without it, the surface would be exposed to the harshness of space. Meteors that usually burn brightly in the sky as shooting stars would instead strike the ground directly. Cosmic radiation would reach the surface unchecked, bathing the Earth in invisible but harmful energy. Life, so carefully balanced under the protection of the atmosphere, would face a sudden and overwhelming threat. Temperature would change drastically as well. The atmosphere helps regulate Earth's climate, trapping heat during the night and reflecting sunlight during the day. Without it, temperatures would swing violently. The side facing the sun would grow unbearably hot, while the side turned away would plunge into freezing darkness. The comfortable range of temperatures that allows water to flow, plants to grow, and animals to thrive would be replaced by extremes too harsh for life. In a matter of hours, Earth would resemble the barren, airless landscapes of the Moon or Mercury, stripped of the balance that has made it a cradle for life. The oceans, so tightly linked to the atmosphere, would also change. As air escaped, the pressure that holds the surface of the seas in place would diminish. Water would begin to boil because of heat, but because of the lack of pressure, great plumes of vapor would rise, joining the exodus into space, leaving behind shrinking seas and empty riverbeds. The delicate interplay between air, water, and land would dissolve, and with it, the cycles of evaporation and precipitation that sustain ecosystems. The Earth's blue oceans, seen from space as a symbol of life, would begin to fade as the water itself followed the air into the void. For humans, the loss of the atmosphere would be almost immediate in its consequences. We could not breathe, could not speak, could not survive for more than minutes without protective equipment. The sense of normalcy, the quiet comfort of a sky above and air around us, would vanish in moments. The world would become alien, unrecognizable, and hostile. And yet, in those first moments of atmospheric escape, there would also be an eerie, haunting beauty. Clouds dissolving into wisps, stars piercing through the daylight, oceans lifting their mist into the black sky. The transformation would be breathtaking to witness, even as it signaled the unraveling of life. The atmosphere is not simply air. It is memory, sound, comfort, and balance. It is the canvas upon which sunlight paints colors at dawn and dusk, the carrier of voices, the regulator of seasons. Its sudden disappearance would remind us how fragile life on Earth truly is. How much depends on the invisible layers of gases above our heads. The escape of the atmosphere would mark not only the collapse of weather, climate, and air, but the unraveling of the very conditions that make our planet unique in the vastness of space. When we think of Earth, one of the first images that comes to mind is water. Vast oceans cover more than 2/3 of the planet's surface, shimmering in shades of blue that are visible in from the distant edge of space. Rivers wind across continents, lakes nestle between mountains, and waterfalls tumble with endless grace. Water, held in place by gravity, defines the very character of our world. It fills the air with moisture, shapes landscapes with its constant flow, and sustains every form of life we know. But in a universe where gravity suddenly stops working, these waters would no longer cling to the ground. They would rise, drift, and scatter, turning oceans into something unrecognizable. Oceans in the sky. The first moments would be strange and mesmerizing. The surface of the oceans, usually calm except for the pull of tides and winds, would begin to ripple unnaturally. Without gravity drawing it down toward the Earth's center, the water would no longer know where down is. Waves that once rolled back toward the shore would instead surge upward, climbing into the air. Droplets would separate from the sea, forming spheres of liquid that floated freely. Imagine standing on a beach and watching the ocean slowly rise away from the sand, lifting like a curtain of liquid glass into the sky. The sight would be beautiful in a way, yet terrifying in its finality. Rivers and lakes would join in this strange ascent. Streams that normally trickle downhill, guided by the pull of gravity, would no longer follow their familiar paths. Instead, their waters would break free of their channels, rising into the air as ribbons of liquid that twisted and coiled like serpents made of crystal. Lakes, usually so still, would lose their boundaries, their surfaces dissolving upward into floating globes. Even the smallest puddles left by rainfall would not remain on the ground. They, too, would rise, joining the great migration of water leaving Earth's surface. As the process continued, water would gather into countless spheres, from tiny droplets no bigger than raindrops to massive globes the size of city blocks. These spheres would drift upward together, colliding, merging, and breaking apart in a slow, silent ballet. Oceans that once stretched endlessly across the horizon would scatter into the sky, becoming floating clusters of liquid suspended above the land. If you looked upward, you would see shimmering globes drifting overhead, reflecting the light of the sun, glowing softly as they turned and spun. The sky would no longer be blue, but silver and white, filled with liquid mirrors gliding through the thinning atmosphere. Life within the oceans would be torn from its home. Fish, whales, dolphins, and tiny plankton would rise with the water that surrounded them, carried into the air inside these floating spheres. Imagine entire schools of fish suspended in the sky, swimming in circles inside drifting bubbles of ocean water. Whales and dolphins, once free to roam the vast seas, would find themselves trapped in smaller spheres, confused and disoriented. Coral reefs, so deeply tied to the ocean floor, would crumble as the water lifted away, leaving their fragile structures exposed. The intricate web of marine life, shaped over millions of years by the steady embrace of gravity, would dissolve. In a matter of minutes, the evaporation of water would accelerate as well. Without atmospheric pressure to hold it down, water would begin to turn into vapor more quickly. Some of the spheres drifting into the air would burst into mist, releasing fine clouds of vapor that would escape into space. Oceans that had once been steady and enduring would vanish into thin air, scattering their molecules across the emptiness. The great cycles of evaporation and rainfall, of rivers flowing into seas and clouds returning water to the land, would end forever. The hydrological cycle, which has governed Earth's climate and sustained life since the beginning, would be broken in an instant. On land, the retreat of water would leave behind landscapes transformed. Riverbeds would dry, valleys would empty, and coastlines would recede into barren plains. The rich deltas that once nourished crops would turn into deserts. Forests, deprived of streams and rains, would begin to wither. Even underground aquifers, normally safe from the immediate effects of the sky, would lose their pressure and begin to rise, releasing their reserves upward. Water that had been stored for centuries beneath the ground would join the escape, leaving the soil dry and cracked. The sound of the oceans would vanish as well. No more crashing waves, no more rolling tides. The deep roar of the sea, which has echoed through human history as a symbol of strength and mystery, would be silenced. In its place, there would be only the faint hiss of vapor rising, and then nothing at all. The quiet would be unsettling, as if the heartbeat of the planet had ceased. For billions of years, the oceans have spoken to us in their language of waves and surf, and without gravity, that voice would fall silent. The climate would be altered beyond recognition. Oceans are not only vast bodies of water, they are regulators of temperature, absorbing heat in the summer and releasing it in the winter. They drive winds and currents, shaping weather across the globe. Without oceans, the planet would lose this stabilizing influence. The balance of warm and cool air, the gentle mixing of currents, the cycle of storms and rains, all of it would collapse. Earth would swing between extremes of heat and cold, unable to sustain the delicate equilibrium that life depends upon. Humans would find themselves in an alien world. The sight of oceans suspended above would be both awe-inspiring and terrifying. Entire seas drifting into the sky would look like a scene from a dream or a painting, but it would also mean the end of everything familiar. Coastal cities would no longer face the danger of rising seas. Instead, they would watch as the seas themselves lifted into the heavens. Ships, once resting on the water, would fall as the oceans abandoned them, left stranded on dry land. Ports and harbors, which for millennia have connected human societies through trade and travel, would become useless monuments to a world that no longer existed. The symbolic loss would be profound as well. For as long as humans have lived, oceans have inspired us with their mystery and majesty. They have been the backdrop of exploration, the source of myths and legends, the provider of food and resources. To see them drift away into the sky would be to witness the unraveling of a story as old as humanity itself. The seas, once a symbol of stability and power, would become fragile and fleeting, breaking apart into scattered droplets that would soon vanish into the void. And yet, in those first surreal moments, there would also be a haunting beauty. Imagine standing where the shoreline once was, looking upward at the sky filled with shimmering globes of water. The sunlight would refract through them, scattering into rainbows that painted the heavens with shifting colors. Whole oceans turned into prisms, casting arcs of light across a darkening sky. Fish gliding inside floating spheres would glimmer like stars caught in liquid constellations. The sight would be breathtaking, almost magical, even as it signaled the end of the world as we know it. The oceans, once bound to Earth, would no longer belong to it. They would belong to the sky, and then to space, slowly dispersing into the vastness. The waters that have cradled life for billions of years, that have shaped continents and nurtured civilizations, would escape into the void, leaving Earth dry, silent, and bare. When gravity disappears, life itself begins to unravel in ways both subtle and profound. Every creature on Earth, from the smallest insect to the largest mammal, is adapted to the pull of this invisible force. Plants push roots downward into the soil, animals develop muscles to carry their weight, and humans build their bones and balance around the constant tug toward the ground. Without that anchor, the rhythms of life, the structures of biology, and the habits of daily existence would begin to drift into chaos. Imagine, for a moment, standing in your home as gravity switches off. At first, your body would feel strangely weightless. The heaviness in your feet, the quiet pressure in your legs, even the familiar sensation of your arms falling naturally at your sides, all of it would vanish. Instead, your body would begin to float. Muscles trained to resist gravity's pull would lose their purpose. Your legs, built for walking, would no longer carry you. Your sense of up and down would blur, and you would drift, helplessly suspended. In space, humans have had glimpses of this in the microgravity of orbit. Astronauts aboard the International Space Station often describe a strange exhilaration as they first float freely through the cabin, tumbling and turning with gentle motions. But the station is still within Earth's grasp, its orbit a dance, sustained by gravity's invisible pull. In a world where gravity truly ceased to exist, that soft dance would become something more unsettling. There would be no center, no downward direction to guide you. Instead, every movement would send you spinning into the air, colliding with walls, ceilings, and objects that were once firmly grounded. Daily life would become unrecognizable. Chairs, tables, and beds would no longer serve their purpose, drifting freely alongside you. A glass of water would not stay on the counter, but would rise into the air, breaking into droplets that floated around the room. Simple acts like eating, drinking, or sleeping would become difficult. Food would not rest on a plate, but scatter into the air in little clumps. Every task, no matter how ordinary, would demand a new way of thinking, but the true impact of losing gravity would be felt within the body itself. Humans are built to live under constant weight. Bones grow dense and strong to support it, muscles thicken to push against it, and blood flows downward with the help of its pull. Without gravity, that balance collapses. Blood and other fluids would no longer settle toward your legs, but would drift upward, pooling in your head and chest. Your face would feel puffy, your sinuses swollen, your eyes under pressure. Breathing would feel different, as the normal rhythm of inhalation and exhalation depends on gravity's influence on the diaphragm and lungs. Over time, the changes would become even more dramatic. Without weight-bearing exercise, bones would begin to weaken, losing density. Muscles, particularly in the legs and back, would waste away from disuse. Joints, no longer pressed together by the force of the ground, would shift in unfamiliar ways. The body, so carefully tuned to Earth's gravity, would struggle to adapt, slowly unraveling in this weightless world. Plants, too, would face a crisis. Roots are guided by a process called gravitropism, growing downward into the soil in response to gravity's pull. Without it, roots would spread aimlessly, unable to find a stable anchor. Shoots, which normally rise upward toward the sun, would grow in random directions, twisting without order. A forest without gravity would look chaotic. Trees sprawling sideways, branches looping into tangled patterns, leaves drifting as their stems lost orientation. Seeds dropped to the ground would not settle into the earth, but would float away, leaving reproduction uncertain. The intricate cycles that sustain forests and crops alike would begin to falter. Animals would also be thrown into confusion. Birds, masters of the skies, rely on gravity for flight. Their wings push downward against the air, creating lift that balances their weight. Without weight, the very concept of flying becomes meaningless. Birds would flap their wings, not rising into the air but tumbling freely in every direction. Insects, too, would lose their graceful patterns of flight. Bees, butterflies, and dragonflies would spin in circles, unable to find balance. The skies, once filled with purposeful movement, would dissolve into aimless drifting on the ground, or what was once the ground creatures would float without control. Dogs and cats, accustomed to running and leaping, would drift with confusion, their paws scratching at air. Herds of animals would scatter upward, their sense of balance shattered. Even the smallest creatures, ants, beetles, earthworms, would be torn from their soil or burrows, carried into the air with nothing to hold them down. The very foundation of ecosystems would disintegrate as life lost its anchor. The psychological effects on humans would be equally profound. Our minds are deeply tied to the concept of orientation. We know instinctively where up and down are, and this helps us navigate the world with ease. Without gravity, that compass would vanish. There would be no floor beneath your feet, no sky above your head. Instead, every direction would feel the same. People would drift in confusion, their sense of place and balance fading. Over time, this disorientation could lead to anxiety, dizziness, and a profound sense of alienation. Sleep, too, would be disrupted. Without the gentle pull of gravity pressing us against the bed, the body would not sink into comfort. Instead, one would float restlessly, turning in the air without stability. The deep, restorative rest that comes from lying safely on the ground would be lost. Communities would struggle to adapt. Buildings, designed to stand upright, would lose their foundation. Floors, walls, and ceilings would no longer have meaning, as every surface became just another plane to drift toward. Technology would need to evolve quickly. Magnetic boots, tethering systems, or artificial gravity machines might become necessary to restore order. Without them, daily life would be filled with constant drifting, collisions, and a lack of stability. And yet, amid the strangeness, there would be moments of wonder. Freed from gravity, the human body could move in ways once reserved for dreams. A gentle push against a wall would send you gliding gracefully across a room. Children would float in joyful spins, turning somersaults through the air without effort. Sports would take on new forms, with balls and players drifting through three-dimensional arenas. The simple act of moving would become playful, and bounded by the rules that once held us to the ground. But beneath the novelty, the loss of gravity would remain a threat. Our biology, our psychology, and our societies are all bound to its presence. Life without a center is not just a matter of floating through the air. It is the collapse of balance, the unraveling of patterns built over billions of years. Without gravity, we would not simply drift, we would lose the very framework that defines life on Earth. Gravity is not only the quiet force that holds you to the ground, it is also the architect of the solar system. From the fiery heart of the sun to the icy reaches beyond Pluto, every planet, moon, asteroid, and comet is held in place by the sun's immense gravity. The Earth orbits with steady precision because of this invisible tether, the moon circles us because of our own gravitational pull, and the stars we see at night are each bound in vast networks of galactic gravity. To imagine gravity disappearing is to imagine not only the collapse of life on Earth, but the unraveling of the cosmos itself. The solar system, as we know it, is built on balance. The planets do not sit still, but move with incredible speed, racing through space in elliptical paths. Earth, for example, travels around the sun at nearly 67,000 miles per hour. At such speed, it should shoot off into the darkness, never to return. And yet, it does not, because gravity acts as the anchor, pulling Earth inward as it speeds forward. This delicate balance, the outward momentum of motion countered by the inward tug of gravity, is what keeps us circling the sun, instead of drifting away. But if gravity were to suddenly stop, even for a single moment, that balance would shatter. Earth would no longer be bound to the sun. Instead, it would continue along its current trajectory, moving in a straight line into the depths of space. Our planet, once safely nestled in the warmth of its star, would be cast adrift into the cold abyss. The sun, brilliant and unyielding, would no longer command its planetary family. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and even tiny Pluto would scatter in all directions, each one flying away on its own lonely path. The moon, so familiar in our night skies, would also break free. Normally, it orbits Earth because our planet's gravity keeps it tethered. Without that pull, the moon would drift away, leaving the nights darker and the tides unmoored. The seas, that once rose and fell in rhythm with the moon's pull, would become restless, their patterns of movement collapsing. For billions of years, Earth and its moon have shared a cosmic dance, but in a world without gravity, that partnership would dissolve instantly. The larger planets would undergo chaos as well. Jupiter, with its immense size, exerts a powerful gravitational influence on the solar system. It shepherds asteroids, directs comets, and stabilizes orbits with its enormous pull. Without gravity, that role would vanish. The asteroid belt between Mars and Jupiter would scatter like dust in the wind, its rocks flying outward in countless directions. Comets, no longer bound to elliptical journeys around the sun, would race straight into the void, their tails disappearing. In the emptiness, Saturn, with its magnificent rings, would lose its identity. Those shimmering bands of ice and rock are held in place by Saturn's gravity, orbiting the planet in delicate harmony. Without that invisible anchor, the rings would dissolve. The particles would drift into space, forming a thin, scattered cloud before dispersing forever. Moons that once orbited Saturn, like Titan and Enceladus, would also leave, floating away from their home planet and joining the wandering chaos of the system. In the far reaches, where Uranus and Neptune circle, slowly at great distances, the same fate would unfold. Their orbits would no longer curve. They would move in straight lines away from the sun. Even the tiny dwarf planets, like Pluto and Eris, would drift, their long and lonely journeys cut short. The carefully woven web of orbital mechanics, the precise balance that is held for billions of years, would dissolve in an instant. What would this mean for Earth itself, set loose on its path through space? At first, little would change. Our planet would continue spinning on its axis, days and nights flowing as they always have. But slowly, the warmth of the sun would fade. Each day, the sun would appear smaller and dimmer, its rays weaker as Earth drifted farther away. Within weeks, the temperature would plummet, oceans would begin to freeze, forests would wither, and the atmosphere would grow colder and thinner. The warmth that sustains life would vanish, leaving Earth a wandering ice world adrift in eternal night. Beyond the physical consequences, the disappearance of gravity would mean the loss of cosmic order. Stars themselves are formed by gravity, pulling clouds of gas and dust into dense spheres that ignite with nuclear fire. Without gravity, no new stars would ever be born. Galaxies, held together by their collective gravitational pull, would unravel. The spiral arms of the Milky Way would scatter, its stars flying apart like sparks from a dying fire. The universe would not merely shift, it would dissolve, its structures collapsing into chaos. For the human imagination, this is perhaps the most difficult part to grasp. Gravity is not just a local force. It is the very reason that structure exists in the cosmos. From the tiniest pebble orbiting a planet to the largest clusters of galaxies, everything depends on it. To remove gravity is to erase the pattern of the universe. The solar system, so carefully ordered, would become a field of drifting worlds, each one a solitary traveler with no home, no orbit, and no connection to the rest. And yet, there is something hauntingly beautiful in this thought experiment. To imagine the solar system without gravity is to recognize the hidden threads that hold it together. We see the sun's light, but not its pole. We observe the planets moving across the sky, but rarely think of the force that guides them. In daily life, we rarely pause to consider that Earth is racing through space at astonishing speed, kept safe by the sun's embrace. The chaos of a universe without gravity reminds us of the quiet miracle of its presence. Astronomers often compare gravity to a kind of cosmic conversation, an ongoing dialogue between masses across space. The Earth listens to the sun's pull, the moon listens to Earth's, and together they dance. Jupiter speaks loudly, shaping orbits far beyond its reach, while even tiny asteroids whisper their influence in subtle ways. Without gravity, that conversation would go silent. The music of the spheres, the harmony of motion, would end. To fall asleep under this vision is to drift into a universe both fragile and immense. The solar system, so solid in our minds, is in truth a delicate balance of forces. Remove one, and the balance collapses. Imagine yourself lying back, closing your eyes, and feeling the slow arc of Earth around the sun, the steady pull that guides our world, the rhythm that has endured for billions of years. To picture its absence is unsettling, but it also deepens our appreciation for the invisible order that makes life and sleep possible. When we imagine a world without gravity, it is easy to focus on the immediate chaos, the oceans rising into the sky, the air slipping quietly into space, or the Earth wandering away from the sun into the frozen night. But beyond the striking images and unsettling consequences, there lies something far more profound, a deeper lesson about the universe and about ourselves. Gravity is not only a physical force, it is a metaphor for connection, for balance, and for the unseen ties that bind everything together. The first layer of this lesson begins with the realization that gravity is invisible and yet essential. We cannot see it or touch it, yet it is always there, quietly holding us to the earth, keeping the atmosphere in place, anchoring the moon above us, and guiding the planets around the sun. This unseen presence mirrors many aspects of human life. So much of what sustains us is not visible at first glance: the bonds of love, trust, community, and memory. Just as the universe depends on gravity to hold its form, so do our lives depend on invisible connections that weave through our days. Without them, we would drift, unmoored, much like Earth would if gravity disappeared. Consider for a moment how we move through life, rarely noticing gravity. Each step we take is guided by it, each breath of air held close by its pull, and yet, it does not draw attention to itself. This, too, is a lesson in humility. The most powerful forces, whether cosmic or personal, are often the quietest. The friend who listens, the family member who supports us without demanding recognition, the simple routines that anchor us. They are like gravity, silent but essential. When we reflect on a world without gravity, we are reminded of how fragile the fabric of existence can be, and how important it is to honor the invisible anchors that make life possible. There is also the lesson of balance. Gravity is not a force that dominates, but one that coexists with motion. The Earth circles the sun not because gravity drags it inward completely, nor because motion allows it to escape, but because the two work in harmony. Balance is not about overpowering one side or the other, but about cooperation. In the same way, our lives depend on balance between work and rest, between ambition and contentment, between holding on and letting go. The image of Earth spinning freely into the void without gravity's steady hand reminds us of what happens when balance is lost. To stay grounded, we must find our own form of orbit, guided by forces that pull us inward and energies that carry us forward. Another layer of the deeper lesson lies in the scale of gravity's reach. The same force that makes an apple fall from a tree also commands the motions of stars and galaxies. It operates on the smallest and largest of scales, uniting them into a single cosmic law. This universality is humbling. It shows us that the same rules apply everywhere, from the quiet corner of a garden to the vast spirals of galaxies millions of light years away. And in that realization lies a reflection of our own place in the world. The smallest acts of kindness, the tiniest decisions, the quietest choices, they echo across the larger patterns of life, Just as gravity's smallest tug shapes the motion of entire solar systems. To think of a universe without gravity is also to think of a universe without structure. Stars would not form. Planets would not coalesce. Galaxies would not spiral. It would be a place of chaos, where matter drifts endlessly without ever coming together. From this, we learn the importance of structure in our own lives. Routines, patterns, and rituals may sometimes feel ordinary, but they provide the framework in which creativity and growth can flourish. Just as the stars owe their birth to gravity's gathering hand, so do we owe much of our stability and meaning to the structures we build for ourselves. Without them, like scattered dust, we would struggle to hold form. There is also a poetic truth hidden within the inevitability of gravity. No matter how high we climb, no matter how far we jump, gravity always brings us back. This is not a limitation, but a reminder of connection. We are bound to the earth, tied to this planet that has nurtured life for billions of years. In imagining its absence, we are reminded of the intimacy of this bond. The earth is not just a place we live, but a partner in our existence, cradling us in its pull, keeping us safe beneath its atmosphere. To dream of a world without gravity is to glimpse what it would feel like to lose that embrace. And in that thought, we grow more grateful for the invisible comfort it provides. The deeper lesson also whispers to us about time. Gravity shapes not only space, but the flow of time itself. Einstein showed us that where gravity is strong, time moves more slowly, and where it is weak, time runs faster. Imagine, then, a world without gravity, where this fabric of time and space becomes loose and undefined. In this thought, we are reminded of the mysterious way time holds us, of how precious each moment becomes. Gravity teaches us that time is not uniform. It bends and stretches, and so, too, in our lives, time feels different depending on how we experience it. An hour spent in joy can feel like a moment. An hour of sorrow can feel endless. In contemplating the absence of gravity, we see reflected the shifting tides of our own lived time, teaching us to value each breath as part of a fleeting, fragile balance. Beyond science and metaphor, the greatest lesson of gravity may be its role as a connector of all things. Every atom in your body is pulled, however faintly, by every other atom in the universe. You are linked, in the most literal sense, to the stars above, to the oceans, to the mountains, and to every person you will ever meet. Gravity is a reminder that separateness is an illusion, that all matter, all beings, all worlds are woven together in a cosmic web. To imagine the disappearance of gravity is to imagine the unraveling of this tapestry. It reminds us that what keeps the universe whole is not division, but connection, not isolation, but togetherness. As we drift into this thought experiment, carried gently by the rhythm of curiosity and imagination, we begin to see why gravity is not simply a scientific principle, but a profound symbol. It shows us the power of the unseen, the necessity of balance, the beauty of structure, the intimacy of connection, and the inevitability of return. It humbles us before the vastness of the cosmos, while also guiding us to reflect on the quiet anchors in our own lives. It teaches us that everything, from the orbit of planets to the steps we take each day, depends on forces we do not always notice, but without which we could not exist. And so, after wandering through this thought experiment, we return to where we began, with gravity itself, the quiet force that never asks for attention, yet holds the entire universe together. We have imagined what would happen if it disappeared, if oceans floated away, if the air escaped, if Earth lost its orbit, and if life itself became weightless and unmoored. Each step of that journey has revealed not only the science of gravity, but the fragile beauty of balance, connection, and structure that shape our world. To picture a universe without gravity is to glimpse a kind of unraveling, a silence where order dissolves into drift. And in that imagining, we find clarity about the world we inhabit. We realize how deeply we depend on the unseen, how connected we are to one another, and how even the simplest step across the ground is part of a cosmic harmony that has existed for billions of years. gravity is more than a physical law. It is a reminder that what is invisible can be powerful, that what is gentle can be essential, and that what seems ordinary, the pull of the earth beneath our feet, the orbits of stars above us is, in truth, extraordinary. Without it, there would be no sky as we know it, no oceans, no time shaped by its curves, no lives woven together by its threads. With it, we belong to something larger, something enduring, something that cradles us as surely as it cradles galaxies. So, tonight, as you drift into rest, let gravity be more than a force in your imagination. Let it be a comfort, a steady presence, a reminder that even in stillness, you are held, you are connected, and you are part of a vast universe bound together by unseen hands. Close your eyes, breathe slowly, and allow that invisible embrace to carry you into the quiet of sleep, where the stars continue their orbits, the earth continues its gentle turning, and you, too, find your place in the great rhythm of the cosmos.